Hey there, and welcome. Today we are cracking open one of the most important ideas in all of modern AI. It's a concept that's working behind the scenes in so many things you use every single day, from your translation app to the chatbot you might have just talked to. We're talking about the Encoder Decoder architecture.
So, to really appreciate why this setup is so clever, we first have to go back and look at the puzzle that AI researchers were trying to solve. Imagine you're tasked with building an AI that can translate languages. It sounds simple enough, but you hit a major roadblock almost immediately.
And this is the absolute heart of the problem. How on earth do you get a machine to read a sentence with, say, 20 words, and then write a brand new sentence with only 5 words, but have it mean the exact same thing? It's this classic challenge of turning one sequence of information into another. And wow, this slide just lays it out perfectly, doesn't it? Take a look at the English sentence on the left. It's long, it's descriptive, it's got all this extra detail. And the French translation, short, sweet, and to the point. You see right away that a simple word-for-word translation would be a complete disaster. The AI has to first understand the entire idea before it can even think about writing the translation.
So how did they solve this tricky problem? Well, researchers came up with this really elegant solution that kind of mimics how a human translator thinks. They gave the AI a two-part brain. And this brilliant idea is what we now call the Encoder Decoder Architecture.
So here's the textbook definition. At its core, it's just a framework, a special kind of neural network that is specifically built to handle this exact problem, taking an input sequence, like a sentence, and mapping it to an output sequence, even when they're totally different lengths.
And this is the magic right here, the two-part system. The best way to think about it is this. The first part, the encoder, is the reader. Its one and only job is to read the original sentence and just understand it. The second part, the decoder, is the writer. It takes that understanding and uses it to generate a brand new sentence. One part understands, the other generates. That's it.
Okay, so that sounds pretty neat. But how does it actually work? Let's pop the hood for a second and see how these two parts talk to each other, because that is where the real secret lies.
So here's the key. The encoder doesn't just pass the words along. No, it reads the entire sentence and it distills everything, all the meaning, all the nuances, all the context, down into one single compact summary. It's like reading an entire chapter of a book and then just holding the core idea of that chapter in your mind.
And that summary has a special name. It's called the context vector. This is the crucial bridge between the encoder and the decoder. It's basically just a list of numbers, but this list of numbers represents that complete mental summary of the original sentence. Everything the writer, the decoder, needs to know is packed into this one vector.
Now, this system was a huge step forward, but it had a weakness. For really long sentences, that single mental summary wasn't always enough. It became a bottleneck. But then a new idea came along that gave this architecture a genuine superpower.
Here's the deal. Imagine trying to summarize an entire movie in a single sentence. You're going to lose a ton of important details, right? Well, the same thing was happening with the context vector. For super long, complicated sentences, that one summary just couldn't hold on to all the important bits and pieces. Details were getting lost in translation. And the solution was something called the attention mechanism. This was an absolute game changer. Instead of forcing the decoder to rely only on that single summary, attention gave it the ability to look back at the entire original sentence. So as it's writing each new word, it can focus or pay attention to the specific words from the input that are most relevant at that exact moment.
The best way to picture this is with a spotlight. The translator isn't just working from a fuzzy memory anymore. Now it has a spotlight that it can shine back onto the original text. So when it's about to write the French word for cat, it can shine its spotlight right back on the word cat in the English sentence to make sure it gets it right. This one idea, it changed everything.
Okay, I know this all might sound a little bit abstract, a little bit in the weeds of computer science. But the truth is,
This whole architecture, with its attention superpower, is running behind the scenes of so many things you use constantly. Seriously, its fingerprints are everywhere. It's the engine in Google Translate, it's how news apps can give you a quick summary of a long article, it's how Siri and Alexa can understand what you're saying, it's even how social media can automatically write a caption for a photo you upload. And yep, it's a core component of dialogue systems like ChatGPT. It's just incredibly powerful.
Now, of course, it's not perfect. Its biggest strengths are that it's super flexible with sentence lengths, and it's great at preserving the overall meaning. But all that attention is expensive. It takes a lot of computing power. And if the decoder makes one little mistake early on, that mistake can snowball and mess up the rest of the sentence. So, researchers are always working to make it even better.
So where does this all take us? Well, this whole two-part brain idea is more than just a clever piece of code. It's a fundamental building block in this massive quest to build machines that can truly understand us.
And you can see how it's evolved over time. It started with simpler models, then it got smarter by learning to read sentences forwards and backwards to get more context. Then came the massive breakthrough of attention, and that directly led to what we have today. Transformer models, which are pretty much the gold standard for most modern AI language tasks.
And that's really the big takeaway here. The Encoder Decoder model was this huge leap forward because it taught machines to separate the act of understanding from the act of generating. And when you think about it, that's a much more human-like way to communicate, isn't it?
Which leaves us with a final, pretty big question. This whole architecture is about getting AI to better understand context and meaning. So as this technology continues to improve, as AI gets better and better at understanding not just our words, but our images and our world, what does that mean for our future? It's definitely something to think about.